Hey guys, welcome to Charlie Talks Tech, and today we are going to talk about a topic which is more of a continuation from yesterday's topic or yesterday's video uploaded based on Qualcomm SNAPDRAGON 835 chipset, which is based on 10 nanometer FinFET technology. So now I would like to describe or give a small overview of what FinFET technology is all about. So before moving any further into this video, I would like to tell, and I assume that you guys know about field effect transistors, FETs, like junction field effect transistors, MOSFETs or metal oxide semiconductor field effect transistors, BJTs, source, drain, and the gate, and how the terminologies are based. So I assume that you guys know. Even if you don't know, I would tell you not to watch this video and wait for the videos in which I will be talking about all these basic concepts which lead to the creation or the adoption of FinFET technology. And people, for those who actually know about these concepts of FETs and how the FETs and dielectrics and source, drain, gate, all these things are, all these things work, the video is for you guys. And I will be explaining FinFET in a very easy concept and in a very easy manner so that even a layman can understand. So what this term is actually FinFET technology. FinFET technology is an adoption where these planar FETs with source, drain, and the underlying gate with high dielectric K is raised from the drain portion and the contacts are made 3D. Like instead of a planar structure, it is more of a three-dimensional structure which allows a lot of transistors to get combined and drive electricity or drive power from a single source. When it comes to planar transistors, if planar transistors are to be implemented in an IC or a processor, for every transistor you need a separate power source, gate, drain, and what it actually does, it actually causes a lot of overheating, and even the sustainability of the processor is compromised in the long run. A lot of heat dissipation, the processor will get heated up, all these things. This is what the concept is all about. Now when you get a 3D structure, like it is raised from the drain, source to drain, current flowing, and the gate is present as the high dielectric K. So if the surface of the drain is raised with a silicon oxide, like silicon oxide and insulator is based on the concept of FinFET technology. There is an insulator layer as the substrate over which we get a silicon oxide layer. All these things make the basics of FET, mostly the FinFET. So the drain structures or the entire gate structure is raised as fin, the envelope. So what it does, if you get a 3D structure, you can add other transistors to the same via a common gate and common contacts. This in turn reduces the power consumption. That's the first thing. That is why FinFET technology is such a craze, because using this technology, the scalability of a processor can be increased without compromising on the performance. And why FinFET is such a craze, there are many reasons to it, but I will be enumerating two reasons. First, as I mentioned, we get a common power source, so the heat dissipation and power requirement is significantly less. And the most important thing, that if a processor is on standby, suppose your desktop is not working and you have kept it in a standby mode, you'll be getting the lowest clock speeds or the operating frequency. Now, if, for example, I'm just giving not a figurative value, just literal value. If your processor, which is a 20 nanometer processor, I'm talking about the idea bridge, if it was not made via FinFET technology, so for example, it will consume around 1 volt for a given amount of time in standby for a particular clock speed, like lowest possible clock speed. However, if you adopt FinFET technology, it reduces by around 30%. So you just need the power source just needs to consume 0.7 volt for the given amount of time for that particular clock speed. So when this standby power consumption reduces and the heat dissipated is significantly less, and you can add more and more number of transistors and can actually work on the Moore's law. Moore's law stated that the number of transistors on a particular IC will actually go on increasing exponentially once the time period exceeds, like year by year. However, if FinFET technology wasn't being introduced, this concept wouldn't have been possible, as if you go on adding a lot of transistors to get that 10 mm or 22 nm, and you go beyond the 22 nm architecture, go lower down that, it will be very hard to include or inculcate all the transistors in a single place because of the power dissipation and even the interference. However, with FinFET, one transistor shares this power from the other transistor due to the common contacts, And this is what the basic of FinFET technology is. So this is what the basic idea of FinFET technology is. And in a layman's language, if you are not understanding what I'm saying, FinFET technology is to make ultra powerful processors, not just the normal planar processors, ultra powerful processors which can be shrinked to significant levels like the 16 mm, 14 mm already existed. 14 mm examples, 14 nm FinFET process examples include Snapdragon 820, Exynos 7420 from Samsung. FinFET actually came way back in 2011 when the first Ivy Bridge processor from Intel was introduced. However, it was already being used in desktop and PCs, and quite recently, like in 2-3 years, companies have tried to inculcate in mobile operating systems or in mobile terminologies so that the mobiles can be shrunk and made smaller and thinner. So with the 10 nanometer process introduced right now with Snapdragon 835, I don't know how low processors can go, like 6 nanometer, 7 nanometer, whether they can go up to that. For the present time, the 10 nanometer process means there are a lot of transistors involved and they are working pretty fine, and there are a lot of performance and a lot of OEMs can be associated. So Snapdragon 835, as I already told you, the more the scalability, it has been shrunk to a significant 10 nanometer size, and these transistors 10 nanometer size things have been included, the architecture is followed. So you can add a lot of things, a lot of AR, VR stuffs with this processor allows you to do. So the more the processor shrinks, you will be getting more number of OEMs and the smartphones are going to get more advanced. So this is what the FinFET technology is all about. This is more of an overview. In my next videos, I will be talking about FETs, field effect transistors, the DC bias characteristics, the threshold. What I would like to say is the leakage currents are less when it comes to FinFET technology. The threshold voltage is lower, the leakage current is 90% less. So these are the benefits of adopting FinFET technology as compared to the conventional planar structures. And I will be mentioning the conventional planar structures also in my subsequent videos with diagrams so that you can relate to the FinFET technology in a better manner. This is more of an overview in simpler terms for everybody to understand. FinFET technology is not rocket science. It is a simple concept where the existing transistor has been modified physically in order to achieve the best possible results. The connections are far superior, the power consumption is less, the power dissipation is less, even the standby power consumption is actually 30% lower than what a normal processor based on planar transistors would do. So this is what the concept of FinFET technology is all about. If you like the content, give me a thumbs up, subscribe to my channel and share this video. There will be more videos like this, more informative videos like this, and I will be giving the diagrammatic representations in my next videos. And everything related to field effect transistors and how the smartphone actually functions in the most basic level will be explained to you. So stay tuned for more, friends. Till then, stay informed.